Let's discuss a few questions on electrochemistry for the IGCSE. So, concentrated aqueous sodium chloride, aqueous sodium chloride, and dilute sulfuric acid are both electrolyzed using inert electrodes. Which row identifies the product at the cathode in each electrolysis? So, in the first case, we have got sodium chloride, which is aqueous. So, we have got Na plus and Cl minus, H plus and OH minus. So, these are the two options we have that could go to the cathode, because those are the two positive ions. So if you compare the reactivity of Na plus and H plus, Na plus is highly reactive, so it would want to remain as Na plus, but H plus being least reactive one will be preferred over Na plus, and this one will go to the cathode and hydrogen will be formed. Okay, so it's either these two. Now let's take the example of sulfuric acid, which is, you will have a lot of SO4 minus, SO4 minus and H plus, and you will also have H plus and OH minus. So the only candidate for the cathode is hydrogen, so B is the answer. Electrolytes can be broken down by electrolysis. Which rows are correct for each electrolyte? You have got aqueous potassium chloride, it's aqueous and dilute, so you will never get potassium, it's always the H plus, and instead of chloride you have to think about OH minus because it's dilute. So at the cathode you're going to get hydrogen, at the anode you're going to get oxygen. That's correct. Concentrated hydrochloric acid, concentrated hydrochloric acid is going to produce chlorine at the anode and hydrogen at the cathode, which is right. Molten aluminum oxide, you have got Al3 plus and O2 minus. So Al3 plus will go to the cathode and O2 minus will be at the anode, but it's given the other way around, so that's wrong. Concentrated aqueous sodium bromide, concentrated aqueous sodium bromide, so you have got sodium and bromide, you will get bromine, which is right. You will get hydrogen because it's aqueous, not sodium. So 1 and 2 are right. A is the option. A is the correct option. Which statement about hydrogen oxygen fuel cells is correct? Hydrogen is extracted from clean air. No, actually oxygen is extracted from clean dry air, not hydrogen. The only product is carbon dioxide. Carbon dioxide is not produced in a hydrogen oxygen fuel cell. It's water that's being produced. The reaction is endothermic. No, a fuel cell should not make an endothermic reaction. Fuels should produce heat, so that should be an exothermic reaction. No toxic gases are produced, which is right, because the only product is water vapor. Which substance produces hydrogen and bromine when electrolyzed? So it produces hydrogen and bromine. So concentrated aqueous copper bromide. Copper, if you have copper, you will not get hydrogen. Copper will be produced. So this will produce copper and bromine. So not an option. Concentrated aqueous sodium bromide. Since it's concentrated, it will produce bromine. That's right. And since it's aqueous, hydrogen will be preferred over sodium, so that is the right answer. Dilute aqueous potassium bromide, since it is dilute, it will produce oxygen instead of bromine. Molten lead bromide will produce lead metal and bromine gas. The ionic half equation for the formation of oxygen during the electrolysis of aluminum oxide is shown. XO2 minus gives O2 plus Y E minus. What are the values of X and Y? So they're asking us to balance the equation. So here there are two oxygens on the right hand side, so you have to give a 2 here. So X has to be 2, so you can rule out the first two options, A and B. Now 1 O2 minus will produce 2 electrons, so 2 O2 minus will produce 4 electrons. So this is the correct option. During the electrolysis of dilute sulfuric acid, hydrogen is collected at the cathode. What is the ionic half equation for this reaction? So you have got H plus in the solution, and that accepts electrons and gets hydrogen. Because hydrogen is diatomic, you have to make it H2. So to balance it, 2H plus on the left, so 2 electrons. So C is the answer. Which statements about the electrolysis of molten lead to bromide are correct? So in lead to bromide, we are looking at Pb2 plus and Br minus ions. So since Pb2 plus are positive, they will move to the negative electrode, which is the cathode, and Br minus are negative, they will move to the anode. Now let's look at the statements. Lead ions move to the anode and are oxidized. Wrong, they will go to the cathode. Lead ions move to the cathode and are reduced. That's correct. Reduction happens at the cathode and oxidation happens at the anode. Bromide ions move to the anode and are oxidized, which is correct. Bromide ions move to the cathode are wrong. So it's 2 and 3. Which substance is not produced during the electrolysis of concentrated aqueous sodium chloride? So you have got concentrated aqueous sodium chloride, that is Na plus, H plus 2 cations, and OH minus and Cl minus are the 2 anions. So you're going to get H plus at the cathode, it will produce hydrogen, and it will produce chlorine at the anode, and you have got NaOH in the solution. So it will produce chlorine, it will produce hydrogen, it will not produce sodium, and it will also produce sodium hydroxide. So it's going to be sodium that is not produced in the electrolysis of concentrated aqueous sodium chloride. A dilute aqueous solution of sodium bromide is electrolyzed using inert electrodes. Which row identifies the product at the cathode and at the anode? So it's dilute aqueous solution of sodium bromide. Since it is dilute, you're going to get oxygen at the anode, and since it's sodium and it's a aqueous solution, you are going to get hydrogen at the cathode. So cathode is hydrogen, anode is oxygen. The option is C. Aluminum is extracted by electrolysis as shown. Which row shows the ionic half equation at the cathode and the anode? So the ore of aluminum is aluminum oxide, so we are looking at Al3 plus and O2 minus, and Al3 plus being positive will move to the negative electrode, which is the cathode, and get reduced. O2 minus on the other hand will move to the anode and will get oxidized and form oxygen, right? So at the cathode it should be Al3 plus getting reduced, and by looking at the equation, you know that during reduction electrons are gained and oxidation is loss of electrons. So this is loss of electrons, so not the answer. This is again loss of electrons, so it's gain of electrons. It's either C or D. Now look at the anode. The O2 minus should undergo oxidation, and in oxidation electrons are released. Electrons are on the product side, right, on the right hand side, so it has to be this one. An electrolysis experiment is done using carbon electrodes. Hydrogen and oxygen are formed at the electrodes. What is the electrolyte? All right, so option A, you have got aqueous copper sulfate. It will not produce hydrogen because it will produce copper metal in place of hydrogen, so not the option. Concentrated hydrochloric acid will produce H2 and Cl2, not oxygen. It will not produce oxygen at the anode. Instead, it will produce Cl2 at the anode. C, dilute aqueous sodium chloride, that will produce hydrogen and oxygen because it's dilute. In place of chloride, OH minus will go to the anode and get oxidized to become oxygen, and in place of sodium, H plus being less reactive, H2 will be formed at the cathode. So C is the answer. Molten potassium oxide will produce potassium metal and oxygen. So not the option. Concentrated aqueous copper-2 sulfate is electrolyzed using copper electrodes. Which ionic half equation describes the reaction taking place at the cathode? So we are looking at the cathode. That's the negative electrode. So it's either copper-2 plus. Since it's aqueous, we also have to consider H plus. And clearly copper-2 plus will be preferred over H plus because copper is less reactive than hydrogen on the reactivity series. Now it's going to be, it's not this one and not this one. So it's copper getting reduced because reduction happens at the cathode. So it's copper getting reduced. And as I said earlier, if you see electrons on the right hand side, that is electrons released or electrons produced, so that's oxidation. During reduction, electrons will be added, so that will be on the left hand side of the arrow. So D is the answer. Concentrated aqueous copper-2 chloride is electrolyzed using copper electrodes. So oxidation happens here and reduction happens here. What happens to the positive electrode? Oxidation. So what will happen to the mass of the copper electrode? So copper will get oxidized and form copper-2 plus, and this copper-2 plus will go to the solution. So the mass of the copper electrode, the positive electrode, will decrease. Now what happened to the negative electrode? The Cu2 plus ions from the solution will accept a couple of electrons and will form copper metal, and the mass of the negative electrode will increase. Iron can be electroplated with zinc to make it resistant to corrosion. Which row about electroplating iron with zinc is correct? So during electroplating, the metal that has to be electroplated should be at the cathode, the object or the metal that is to be electroplated. The metal you are using to electroplate the other object is taken as the anode. So in this case, anode should be zinc and cathode should be iron. So the positive electrode anode should be zinc. Negative electrode cathode should be iron, and electrolyte should be a solution, a conducting solution, an ionic solution of the metal on the anode. So we have zinc at the anode, so it has to be zinc nitrate and not iron nitrate. Concentrated aqueous sodium chloride is electrolyzed. Which equation represents the reaction at the cathode? So you have got Na plus and H plus, and clearly H plus will be preferred over Na plus. And what happens to H plus? H plus will undergo reduction by accepting an electron to become hydrogen, but hydrogen is diatomic, so you have to consider this one. So this is the equation. Aqueous copper sulfate is electrolyzed using carbon electrodes. Which statement is correct? So this is aqueous copper sulfate using carbon electrodes. So you have got copper-2 plus, H plus, and SO4 minus and OH minus. So bubbles of hydrogen are formed at the anode. Hydrogen would never go to the anode because anode is positively charged, and hydrogen is also positively charged. Bubbles of oxygen gas are formed at the cathode. Oxygen is negative, cathode is negative, so that's not the combination. Copper is deposited at the anode. Copper will not be deposited at the anode. Again, copper is positively charged. The blue color of the solution fades is the right answer because the copper-2 plus will go from the solution to the cathode and get deposited. So the concentration of copper-2 plus will reduce in the solution, and the blue color of the solution fades. The diagram shows a simple cell. Which pair of metals produces the largest voltage? Alright, So the largest voltage produced, or the amount of voltage produced, depends on the reactivity differences between the metals used. So you have to look at the reactivity series and pick a pair of metals which are far from each other, not closer at all, right? So you are looking at something at the top and at the bottom, and clearly copper is here, magnesium is here, and everything else comes in between, right? So magnesium and iron, it cannot be the option. Magnesium and copper can be the option. Zinc and iron, no, zinc comes here and iron comes here, so it has to be magnesium and copper.